All right, let's solve this equation. So I have 5 cosecant theta equals minus 3 equals 2. So what I'm going to do first is I'm going to add 3 to both sides. And I get 5 cosecant theta is 5. And then I divide by 5. And I get cosecant theta is 1. Well, when is cosecant theta 1? Well, cosecant is the same as 1 over sine. And so sine theta is 1 at pi over 2. If I'm looking from 0 to 2 pi. Now what if I was looking for all theta, wherever? Well, then I know it's pi over 2, and then I know it's all pi over 2 plus every 2 pi, right? So plus 2 pi. So plus 2 pi n, because I can keep on adding. So if I were looking at all solutions, it would be plus 2 pi n, because every pi, wherever it ends up being pi over 2, or that's the reference angle. So with a period of 2 pi, it would always be 1. Let's look at this one. Tangent squared theta equals 1/3. And when I want to solve it, I want to take the square root. So now I have tan theta equals the square root of 1/3, which is the same as the square root of 3 over 3. Because it's right, it's 1 over radical 3, and I rationalize it. So when is a tangent, and it's plus or minus because it's a square root. So when is a tangent radical 3 over 3? Well, it's radical 3 over 3 when sine is pi over 3. So it's pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So if I was looking only between 0 and 2 pi, it would be all of those, because I'm looking at plus or minus, and so I have to look at all the quadrants. If I was looking for all thetas, then it would be n pi over 3, because anything times any n times pi over 3 will give me what I'm looking for. Let's look at this last one. I have 4 sine squared theta minus 3 is 0. I'm going to add 3 to both sides. I have 4 sine squared theta is 3. I take the square, divide by 4, sorry, and I have sine squared theta is 3/4. I'm going to take the square root. I have a plus and minus, so I have plus or minus radical 3 over 2, and that is when theta is pi over 3, 2 pi over 3, 4 pi over 3, or 5 pi over 3.